right, good day geometry. Joey, are you ready? 'Cause we are. We are recording our last objective of the unit, PO43, the inverse of sine, cosine, tangent. So the other day, we learned what sine, cosine, tangent, what those buttons mean on your calculator. If you look just above the button, not on the next button, but on the calculator itself, you'll see sine -1, cosine -1, and tangent -1. Okay, that -1 means the inverse of. And like we've talked about, we've done conditional, converse, inverse, contrapositive statements.
It says domain.
Well, don't press it yet. You don't know what you're doing yet. Okay, just hold up. Okay. The inverse is kind of like the opposite of. Okay. So we use sine, cosine, tangent to find sides of triangles. We use the inverse of sine, cosine, and tangent to find angles of right triangles. Everything that we've done up to this point, we've always known at least one angle, with the exception of the Pythagorean theorem. Right? 45, 45, 30, 60, we needed an angle there. Sine, cosine, tangent, we need an angle there. But what if the angles we want to find? Right? Everything else we've done deals with side lengths. Now we're talking about how can we get the angle. So consider this. We've got a triangle here. It says find the measure of angle A. And so this is the angle we want to find. So just like with sine, cosine, tangent, we are using an angle. And we want to know what is the location of the two sides that we're interested in. So Damien, from this angle A, what's the location of the side that is 5?
Start with top.
Someone else.
Adjacent.
Opposite. Okay? From angle A, side BC is the opposite side. What's the location of the 11, Kylie?
Adjacent.
It's not adjacent. I mean, it is adjacent, but
Hypotenuse.
it's the hypotenuse. Yeah, you gotta watch out for that.
I'm smart.
Okay? Damien, you need to find out. So to solve for angle A in your calculator, what you're going to use, because sine, as we know, is still opposite over hypotenuse, but by using the inverse of sine, okay, so go ahead and press the second function and the sine button, and it'll give you the sine to the negative first. The opposite side is 5. The hypotenuse is 11. Close your parentheses.
Wait, what do I do?
How do we get the 5 over 11?
You press the 5 button,
It's
and
27.
then press the division symbol, and then type in 1 twice. That'll give you 11.
0.04.
Okay? Raise your hand if you tell me what you got. Joey.
27.04.
27.04. Second that. Noah, Christopher.
I
Okay?
can second that indeed.
Angle A equals 27.04 degrees. Okay? So same idea. Sine will always be opposite hypotenuse. Cosine will always be adjacent hypotenuse. Tangent always opposite over adjacent, but we're using it a different way. We're using the sides to solve for an angle instead of the angle solving for a side. Yes, Joey.
If you were to write it out, would you write the degree as theta, like the Greek symbol?
No, you'd use the degree symbol. The theta is used more for, is it radians or gradients, or different types of degrees? You won't use it here.
Oh, okay.
Yeah.
What's a theta?
It's like Greek letters, like pi is. Pi comes from the Greek alphabet. Anyway, Damien.
How do I know the 5 goes over the 11?
You know the 5. Who can answer that? How do we know the 5 goes in the numerator of this fraction here? Sophie. Because of SOHCAHTOA. In the sine ratio, the opposite side is always the numerator. That's why it's SOH, S-O-H. Okay? The opposite side, which is 5, is always the numerator.
Oh.
Alex. Yes. Correct. Yeah, if you put the larger one first, Alex, notes you do get a domain error, and that should clue you when you did it wrong anyway. Okay? The inverse of cosine. Again, we're solving for angle A. Right? And this time we know that we're using cosine because the 7, one of the sides that we're interested in, is the adjacent side, and the 12 is the hypotenuse. And The only ratio that includes adjacent and hypotenuse is cosine. So cosine being adjacent over hypotenuse, in this case, we've got the cosine -1, the inverse of cosine. And what order are these sides going in here? What order are these sides going in here? Go ahead, Daniel.
7/11.
Adjacent over hypotenuse, which is 7/12.
Because it's so contour.
Yep, but it's 7/12, not 7/11. Okay. And what do you come up with?
54.31.
54.31 degrees.
Wow.
How do we know
got
we're
that.
solving for A?
Because you were
I
told.
got it.
You can solve for C also, but in this case, we're solving for A. Here's an example of tangent, right? Again, solving for angle A. And we know this is tangent because the location of the two sides, 10 is opposite, 22 is adjacent. The only ratio that includes opposite and adjacent is tangent. And the tangent ratio is opposite over adjacent. And so in your calculator, inverse tangent, what's the order? Kylie?
10 over 22.
10 over
I
22.
got it.
And Joey?
24.44.
24.44 degrees. Do I have a second on that?
Yeah.
Very good. Okay. So similar things to what we're doing, only a different function. Okay, we're using it to find something else. Damien.
How would we find the angle C?
If we wanted to find angle C,
Oh, we
Okay.
just use the 90
Adjacent
degrees as
opposite.
the other one.
we would still use tangent. Only this time, what's our opposite? What's our adjacent? It's flipped, right? From angle C, 22 is the opposite, and 10 is the adjacent. So in this case, it'd be tangent -1 of 22 over 10. Okay? And that would give you angle C. What would another method be, perhaps more efficient method be to solve for angle C, having already solved for angle A? Lisa?
You could just flip or add 90 plus the number and then
Right, knowing that angles A and C have to sum to be 90 because we already have one 90-degree angle, we could just subtract 24.44 from 90,
I got
and that's going to give us 3 mini angles. But this is clearly more fun than that, so
No.
inverse tangent works. Okay, but if you had to solve for angle C first, without angle A, that's the calculation that you would use there. Okay? Questions on this? Comments, concerns, complaints, comments, congratulations, criticisms? Alex?
when I put 22 divided by 10.
We're good? Okay. Anything else? Okay. Your toolbox is going to be put to the test here in PO43, because as much fun as it is to use that sine, cosine, tangent, and inverse, really the goal now is to do what's called solving a right triangle. Okay? And to solve a right triangle means that you are finding the measure of each angle and each side. Oh. David, have a seat, please.
No, I actually have to go.
No, I'm telling you to sit down, please. Solving a right triangle means you're finding the measure of each angle and each side. So, in this first one, we're given angle E, that's our right angle. We're given DF, we're given DE. We need to solve for the other 3 parts. Side FE, angle D, and angle F. Okay? You're given 3 of the 6 pieces, right? 3 angles and 3 sides total. You're given 2 of the sides. So you have 1 side left to solve for. Now you can go, David. Thank you. And you're given 1 angle. That's how we know it's a right triangle. And we're looking for the other 2 acute angles. Someone give me a way to solve for one of these 3. What do you want to use? Use anything in your toolbox. Wide open. Jack.
Yeah, you have to use, so it'd be sine, maybe no, opposite. No, it'd be, opposite.
What are you solving for?
I'm solving for D, I believe.
Angle D. All right.
Or whichever one is across from F. So
Across from
angle F. I'm solving for angle F.
Solving for angle F. Okay.
Yeah.
So solving for angle F,
Yeah.
what are you going to use?
So you see that 10 is the opposite.
Yep.
And then 17 is the hypotenuse.
Yep.
Which is, I don't know what that is.
So solving for angle F, we've got the opposite and the hypotenuse. Which ratio uses opposite and hypotenuse? Lexi, which angle uses opposite and hypotenuse? Not a ratio. I'm looking for sine, cosine, or tangent here. Sine does, right? And since it's an angle, we're using the inverse of sine. Opposite over hypotenuse, 10 over 17. And that's going to give us the measure of angle F, which is 36.03. Take your word for it there. All right, now we've got this. Who wants to give me what we can solve for at X and how to do it? Alex?
You can solve for D by doing 36.03 minus.
Sure. Solving for angle D now, since we've got two of the angles, all we've got to do is take our right angle 90 and subtract what we got for angle F. Essentially taking angle E and subtracting angle F. That's going to leave us with angle D. And 90 minus 36.03 is?
Oh, ask yourself the next one.
53.97.
There's also a harder way to do it.
Your other way would be using sine and cosine tangent. You can use that a second time, inverse of.
Or could you just, or the harder way with the.
And how are we getting side FE here? Kylie?
Do the Pythagorean theorem.
Pythagorean theorem is one way. What's the second way we could use? We could use sine, cosine, tangent. Now that we have an angle, right? If we really like sine, cosine, tangent, we could use that also. But using Pythagorean theorem, a squared plus b squared equals c squared. We'll label our unknown leg b. And we get 100 plus b equals 289. Oop, b squared. B squared equals 189, which is...
How in the world did you do this?
How in the world did I do this? Someone help out.
No, just FE, like, I'm confused on that FE.
So FE is the side here.
Yeah, I got that.
When we know two sides of a right triangle, our go-to method, Pythagorean theorem. That's what I just did there. So Pythagorean theorem is a squared plus b squared equals c squared. The sum of the legs squared will equal the hypotenuse squared. So I plugged in 10 for A, because that's one of the legs.
Oh, yeah.
I left B as B, because that's what we're trying to find. I plugged in 17 for C.
And then you just. Oh, you did that.
The answers are all over different.
Yeah, I got you.
Yep. And then if you solve this, simplify it down, you get 3 root 21, which is what you would have on a test if I asked you to do this, 3 root 21. Anthony's saying if you use sine, cosine, tangent, you get a little bit slightly different answer. And why would that be? Because you're using a rounded value. If you use these angles that you found here, you did round these. So if you use them in sine, cosine, tangent, you're rounding multiple times there too. Your answer is going to be slightly off. Okay. So on a test, as long as you're within like 0.25, then you'll be okay. If you're outside that range, then either you did something wrong or you rounded too generally. You need to be more specific. Nearest hundredth is where you should go. Max.
For like the EF, could you just like write a decimal as the answer?
It depends on what I ask you for. I think on the test, on the Pythagorean theorem section, I asked you for a simplest root form. But on this one, I think I let you put a decimal.
How do you put that into a decimal?
Root 189. You can just take the root of 189 in your decimal. Second function, root t. 189.
So what did he write? 89?
13.7472
189.
708.
289 minus 100 would be 189.
Oh, he said 289. 189. Okay.
Yes, Alex.
Did you use cosine
Cosine?
and you showed that you did it for FE?
Yeah.
Would you take a decimal?
Yeah, what decimal did you get?
I got 13.75.
13.75. If you take the root of 189, you should get something right around there. You get 13.75 that way too. So really, it's not going to be that far off. So yes.
So you would
Yes, I'll accept that. Yep. Yep. All of these tools in your toolbox are eligible. Beckman.
So above it, and it got different answers.
Tell me what you did.
I did the same thing with above.
So for angle F, what did you do? Why'd you check your work and then yeah?
Behind you, there's like all those words. Can I please erase those?
No.
They're really being distracting.
No, it's fine.
No, it's yeah.
All right, next one. In this case, you are given one side and one angle. So you are tasked to find two sides, GH and GJ, and then one angle, angle G. Someone give me a method to find either of these three pieces. Dig in that toolbox. Max, what do you want?
Do like the tan 28.9.
What are you solving for, first of all?
G.
Okay, solving for angle G?
Yeah.
So solve for angle G, you want to use tangent? How are you going to use tangent to solve for angle
Or actually,
G?
no, the side. Side GH.
Shh, folks.
Side GH.
Okay, going for side GH first, which is this one here. He wants to use tangent because from the angle that we know, which is 28.9, GH is the opposite, 13 is the adjacent, and that ratio is going to be tangent, right? So to set this up, we've got the tangent of 28.9. The tangent ratio is opposite over adjacent. The opposite side we don't know, so that's going to be our variable. We're putting that over the adjacent side, 13. We like this because this is one less step of the process. We don't have to multiply tangent 28.9 by 13. And Max, what'd you come up with?
I got 7.18.
Do we have a second on that?
Yep.
7.18? Excellent. Okay. Did you use tangent? What did you put in? Tangent of 28.9?
Oh, I put 38.
What do you want to do next? Sophie?
I did angle G and I did the tangent or whatever.
Yeah, what's the most efficient way to find angle G here?
90 plus 28.9 minus 20.
Sure, or even more efficient than that. You know this is 90 here. These two acute angles have to add to be 90 to complete the 180 degrees. Subtract 28.9 from 90. What'd you come up with?
61.1.
61.1. Do I have a second on that?
Yeah.
Okay. So angle G is just found with subtraction because we know one of the other two angles. And how are we going to go with GJ? The options are, well, not endless here, but we've got plenty of them. What do you want to use? Damien.
Pythagorean theorem.
Pythagorean theorem. Set it up for me, Damien.
Okay, so we got 13 squared. 13 squared plus b squared. Or no. Yeah, plus b squared equals c squared.
Well,
We don't know.
we have to be able to use B or C.
I
You
know
can't have two variables.
7.18
7.18 squared.
and then equals c squared.
Good. Okay. 13 squared is 169. 7.18 squared is going to be about 52-ish? 51.1. And that equals c squared. So that gives us 220.1.
That's not right.
That's not right?
So you 220.55.
Oh, sorry. And this is where rounding comes into play, right? Some of you rounding differently will get slightly different answers here. I was told that 7.18 squared is 51.1, so that's what I was using here. If you did it differently, if you rounded differently, you might get a slightly different answer, and that's okay. That's kind of those things that we understand might happen here. Okay? So we'll just go with what I originally had, 220.1 equals c squared. If you have 220.55 equals c squared, it's not going to make a big difference because when you take the root of 220.1 or 220.55, it's going to be very, very similar. Okay? Someone who used 220.1, what is the root of 220.1 rounded nearest hundredth? Yeah.
14.84.
Okay? Someone who had 220.55, what's the root of 220.55?
14.85.
Ooh. See?
That's pretty close.
That'll be okay. You will be fine.
I got 14.
Okay. 14.77, what did you round to?
I did the cos.
Okay, so if you're using cosine here, your answer might actually be a little more accurate because you're using an actual value that hasn't been rounded. Using the 7.18 squared, because we rounded that here, your answer is probably a bit more accurate than what we have here, which is why on the test, as long as you're within 0.25, you'll be fine, right? Because you had, what, 14.77 you said? That's still only 0.07 away. Okay, so you're still well within that acceptable range. Yeah.
So I also used cosine, but I got 14.85.
Okay, again, rounding, right? It all depends on how you round, when you round, what place you round to. Don't get caught up on being that far off, okay? Because when you round, that's what happens, okay? That's what happens.
So it's an 14.85.
I would accept 14.84, 85, 77, right? They're all within that acceptable error range, right? Your homework for tomorrow, you'll also get your practice test tomorrow. It will not be an assignment. We'll do it in class in preparation for Thursday, Friday. But in your textbook, I'd like you to do, and a request. When you go grab textbooks, please put them back when you're finished. Last time I had 3 books that I had to put back myself. I'm going to hide all the extra ones if you don't return them to their proper place.
Anthony, give me a mic.
On page 486, I'd like you to do
No.
10.
I can't.
Oh, wait a minute.
10, 11, 12.
No, let's do
13, 14, 15.
10, 12, 14, 15. Folks, make sure you show your work. Last time we kind of ran into an issue where people were doing work on a separate sheet of paper and not having that paper there. I need to see your work for this assignment to have credits. I must see your work. All right, folks, that's how you math. Like and subscribe.